Ask a chatbot a simple historical question. You type, "Who invented the light bulb?" You expect to see Thomas Edison, but instead it gives you the name of a scientist who never lived. The formatting is flawless, the grammar is perfect, the paragraphs flow logically, and every single word is a complete fabrication. We rely on these systems to write complex computer code, pass medical licensing exams, and generate intricate art in seconds. Because they perform these massive tasks so well, it is incredibly easy to assume we are talking to a flawless, omniscient digital encyclopedia. Then it casually invents a historical event. It cites scientific studies that were never conducted and references federal laws that do not actually exist. When this happens, the system isn't glitching, it isn't trying to deceive you, and it hasn't been hacked. To understand why a highly advanced machine confidently fabricates information, we have to let go of everything we assume about how computers store information. The central misunderstanding is how these models process knowledge. They do not contain an internal hard drive of facts, and they do not run a search through a database to find the correct answer to your prompt. To see how they actually operate, look at human instinct. If you hear the phrase, "the capital of France is," your brain instantly supplies the word Paris. You didn't run a web search, you completed a recognized pattern. Large language models apply this exact mechanism, known as next word prediction, at a massive scale. They ingest billions of pages of text during training, allowing them to calculate the exact mathematical probability of which single word should logically appear next. A hallucination happens the exact moment one of those mathematical predictions drifts away from objective reality. Once it picks the wrong word, it continues predicting the next logical word based on that initial error, building an entirely fictional narrative. This creates the probability paradox. These systems are mathematically optimized purely to continue a recognizable language pattern. They are not optimized to verify if that language is actually true. If a machine is essentially just playing a massive game of guessing the next word, why does it always sound absolutely certain of its answers? Because confidence has nothing to do with accuracy. During training, the system analyzed how human experts explained concepts. It learned that authoritative, definitive language is simply a highly probable pattern for answering questions. This mimicked certainty acts as a perfect mask. It wraps completely fabricated data in the reassuring tone of a professional, making it incredibly difficult for a user to spot the deception. Engineers are actively fighting this flaw. They are building complex, human-reviewed feedback loops and integrating live web searches to force the models to verify their own claims before showing them to you. But predicting probabilities based on incomplete data naturally produces uncertainty. Because this guessing mechanism is the foundational architecture of the technology, hallucinations are a deeply ingrained feature that we may never completely eliminate. This means we have to completely rethink our relationship with this technology. We have to stop treating these systems as flawless oracles and start treating them as highly capable, yet imperfect, creative assistants. There is a new division of labor. The machines excel at the heavy lifting, rapidly generating ideas, synthesizing massive datasets, and calculating complex language probabilities in milliseconds. But we have to provide the oversight. Humans remain the essential compass for establishing objective truth, understanding real-world context, and making the final call on high-stakes decisions. Relying purely on a language model for medical, legal, or financial advice without checking trusted sources is an incredible risk. The most successful users going forward will be the ones who verify the output. Every time you hit enter on a prompt, a vast network is executing an extraordinary mathematical trick. It is simply guessing the next word, billions of times, in a matter of seconds. That immense scale of pure prediction is exactly what gives artificial intelligence its staggering utility, while practically guaranteeing it will occasionally fail. Recognizing the vast difference between calculating probability and knowing the truth is the most critical skill you can develop today. If you found this breakdown helpful, make sure to hit the subscribe button to keep learning how these systems shaping our world actually work.